All right, we're up to 2-4, day 2. More in regards to the letter I given to you differently, okay? We got to understand these examples before we understand the examples that integrate the letter I. So let's start here. Before I jump into this, let's go over a couple things. First of all, square root of 2 times the square root of 2 is, well, technically it's the square root of 4, but hopefully you're thinking, wait a minute, you gave us a shortcut. If you square a square root, which by the way, you could write it like this, and then you go, you're squaring a square root, it's kind of like this 2 and this square root just cancel, you get 2. You're like, okay, yeah. But now look at this, 7/12 times 6 over 6. Well, some of you would go, oh, that's 42. The 7 times 6 is 42. 12 times 6 is 72. Then you would take a long time to reduce it. Now, I want you to notice something. What's 6 over 6? 1. What's anything times 1? Well, that would just be itself. So I really don't want you to take that step. I want you to realize anything times 1 is itself. So in math, you can change the way something looks as long as you don't change its value. So with that in mind, we got to get that square root out of the denominator. Now, how do you do it? Well, we're going to integrate these two rules. We're going to multiply this fraction by something that equals 1. Now, I'm concerned about this. So what times the square root of 2 will get rid of the square root? Well, itself. Why? Because when you square a square root, the roots fly off. But in order for this fraction to equal 1, I got to do the same thing in the top. And now I multiply straight across. Now this may not make sense to you guys right now. I haven't taught it really, but I have said things like the square root of 2 times the square root of 3 is the square root of 6. And that's okay. I've also, you guys have been doing this forever. 3 times 7 is 21. But you cannot mix oil like this. Let me show you an example. 4 times the square root of 9. That's a good example, okay? 4 times the square root of 9, if somebody tried this and went, oh, I'm going to multiply 4 times 9, I'd get the square root of 36, which is 6. But under further investigation, that's wrong because the square root of 9 is 3, and 4 times 3 is 12. That's correct. So what I teach is, think of this as oil, think of this as water, and if I poured oil and water together, they would mix. They never mix. So don't think for a second that 3 times the square root of 2 is the square root of 6. It's just, let me erase this, it is 3 times the square root of 2. Don't do too much with that. But notice I got water, water, they mix. Square root of 2 times the square root of 2 is the square root of 4, which is 2. And I'll always check this to see if you can reduce it. Check your oil. See that little connection, little life lesson? But you can't reduce it, so this would be my answer. Okay. Now, what about this? Well, we're all creatures of habit, so I bet you if I left you on your own, you might go, all right, I'll try that again. I see the square root of 2 down here. So I got to go square root of 2, square root of 2. This is oil, that's water, so I got to multiply them, but don't multiply them. And then I have to distribute this to both things. Now remember what our goal is. Our goal is to get the radical out of the denominator. You'll hear me in class say, get the radical out of the basement. There's a long life lesson there, but I'm not going to waste this video with that. Square root of 2 times the square root of 2 is 2. But the square root of 2 times 1 is the square root of 2. Now, my efforts didn't work. Must be a trick. See that the radical's still down here. I can't cancel these out. That's mathematically a no-no. So there must be something else that I can do. Let me get rid of this. And the answer is you're going to multiply by a fraction. Notice I made this a little bit bigger. This fraction has to equal 1, just like this one did. You're going to multiply by this things, get ready for this, conjugate. That's a fancy word. Well, the conjugate is just the same thing here, then you change the sign. So if that's plus, this has to be minus. Now that's what I added on the bottom. Now some of you are like, well, why does that work? I'm going to show you. Square root of 2 minus 1. Notice the top has to be the same as the bottom in order for it to equal 1. In the top, I'm going to get 3 square root of 2 minus 3 all over. Now watch this. Now we have a FOIL situation. I'm going to do my work over here. Square root of 2 times the square root of 2, the roofs fly off. Outside, I get negative square root of 2. Inside, I get positive square root of 2. 1 times negative 1 is negative 1. I want you to concentrate on these middle two terms. Those will cancel. And 2 minus 1 is just 1. Now you can leave your answer here, but the book is going to just simplify that a little bit and that would be your answer. Now here comes a what if. That is the answer to this problem, so don't let me confuse you. But what if this was a 3? Then you would go, aha, this is the same thing as 3 square root of 2 over 3. I'll just put a plus in there. Negative 3 over 3. See, this thing will continue simplifying, because 3 divided by 3 is just 1. So I get the square root of 2, and negative 3 plus 3 is negative 1, or plus a negative 1. That's a what if, so be on your guard for that. Now, the whole lesson yesterday, or the previous day, had to do with the imaginary number I. And here it is, it shows up. Don't forget what I is. I is the square root of a negative 1. So this is just a little bit of a hidden math problem, very similar to this, where we have a square root in the denominator. Don't forget the rule. The only thing that works is by multiplying the bottom by its conjugate. But if I do that to the bottom, I have to do the same thing to the top. So if I distribute, I get 20 plus 4i all over. Get rid of this. Now we FOIL. 5 times 5 is 25. Outside would be 5i. Inside would be negative 5i. Negative I times positive I is a negative I squared. Now, first things first, look at it. Those cancel. Now I end up with 25 minus I squared. What is I squared? I squared can always be replaced with a negative 1. So I have 25 plus 1, which is 26. A lot of little rules. Okay, I'm not done yet. Let me put some more stuff on the board here. Okay, 3 more problems that fit into the category of pre-lesson. So we're going to really open up the hood and take a look at what's going on. So the book is going to tell you on a few problems, hey, use factoring to solve problems like this and this. We're not going to do that, okay? We're going to use what we've been using that seems to be a lot easier. But let me explain something. Earlier this trimester, I did say one time, that doesn't mean you're going to remember it, but I said there's no way you can factor a sum of 2 squares. Like you would try maybe x plus 2 equals 0. Problem is, if I FOILed this out, I'd get x squared plus 2x plus 2x plus 4. And I'd get x squared plus 4x plus 4, which, by the way, does this look like this? No. That means I factored it wrong. By the way, it is impossible to factor a sum of 2 squares. So the book has examples where they really make it complex, when I just don't think it needs to be. How are we going to solve this? Well, we're going to get our x squared alone. So we get x squared equals negative 4. Bada boom, bada bing, do the right thing. Don't forget that. So we get x is plus or minus the square root of negative 4. Now, is our job done? No, 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 no. That's considered not simplified. What do you do when you have that situation? You take the I out. Are we done? No, because the square root of 4 is 2. So we get plus or minus 2i. I throw this one on here just for free. Difference of two squares, absolutely factor that. X minus 2, x plus 2, and I'd say, hey, 2 or negative 2. There's my answers. Now, what if you're like, I don't even like factoring? Well, then on this one, you could add 4, x squared equals 4, and then go bada boom, bada bing, do the right thing, get plus or minus 2 in a different way. In summary, you cannot factor a sum of two squares. So I say isolate the squared term, bada boom, bada bing, do the right thing. It'll take you to the promised land every time. How about number 5? A little more stuff going on. We cannot factor a sum of two squares. So we're going to subtract 25 from that side and this side. So we get 9x squared equals negative 25. What are we ready for? Well, we could go bada boom, bada bing, do the right thing right now, but I'm going to divide both sides by 9 to get started. And then we get negative 25 over 9. Now I have isolated my squared term. We are ready for the good old bada boom, bada bing, the whole thing. Do the right thing. So I get x is, take the I out. I'm left with 25 over 9, which the square root of 25 is 5. Square root of 9 is 3. So I put that all together, I get plus, forgot the plus or minus. See how easy that is? Plus or minus 5i all over 3. Why is the I in the top? Because it's really I over 1. I hope that makes sense. So you're going to have a few problems like this on your homework. But this is your pre-lesson. I'm going to do a couple sample problems on the next video if you need them. And you should be good to go for your homework.